Next theorem, the polar p x1 y1 with respect to the circle x square plus y square plus 2gx plus 2fy plus c equal to 0 passes through q x2 y2, that is another point if and only if the polar of q passes through p. Right? We'll see the proof. Given circle equation, that is the general equation x square plus y square plus 2gx plus 2fy plus c equal to 0, that is equation number 1. We know that the equation of the polar of p x1 y1 with respect to 1 is x x1 plus y y1 plus g into x plus x1 plus f into y plus y1 plus c equal to 0, that is equation number 2. Suppose the polar of p x1 y1 passes through q x2 y2, that is 2 passes through polar, right? 2 passes through q x2 y2, then q satisfy the equation 2, right? So instead of x you can put x2 and y is equal to y2. So you will get x1 x2, that is x2 x1 plus y2 y1 plus g into x1 x2 plus x1 plus f into y2 plus y1 plus c equal to 0, that is equation number 3. We know that polar of q x2 y2 with respect to 1 is x x2 plus y y2 plus g x plus x2 plus f y plus y2 plus c equal to 0, fourth equation. So 3 implies p x1 y1 satisfy 4, right? 4 passes through p x1 y1, because if you put instead of x x1 y is equal to y1 in fourth equation, you will get third equation, right? So that means p x1 y1 satisfy fourth, that is 4 passes through the point p x1 y1. So therefore the polar of q passes through p. In the similar manner, converse part can be proved. So if we can put if and only if in the all the if condition, you will get the reverse, right? So same procedure, right? So conjugate points. Next definition: 2 points p x1 y1 and q x2 y2 are said to be conjugate points with respect to the circle x square plus y square plus 2gx plus 2fy plus 2 plus c equal to 0 if q x2 y2 passes through the polar of p x1 y1 vice versa. Like the previous result, if a polar of p passes through q x2 y2 and the polar of q passes through the point p x1 y1, then the 2 points p and q are conjugate points, right? Condition for the conjugate point: the condition for 2 points p x1 y1 and q x2 y2 are conjugate points with respect to the circle x square plus y square plus 2gx plus 2fy plus c equal to 0 is x1 x2 plus y1 y2 plus g x1 plus x2 plus f into y1 plus y2 plus c equal to 0. That is the condition, right? Then conjugate line, right? p x1 y1 and q x2 y2 are conjugate points with respect to the circle x square plus y square plus 2gx plus 2fy plus c equal to 0. Then the polar of p and q are called conjugate lines with respect to the given circle. So first note, 2 lines are conjugate if and only if pole of one lies on the other line, right? Result 2. That is next theorem. Let x square plus y square plus 2gx plus 2fy plus c equal to 0 be the given circle with radius r, and L1x plus M1i plus N1 equal to 0 and L2x plus M2y plus N2 equal to 0 be 2 straight lines. Then the following statements are equivalent. First statement: L1x plus M1y plus N1 equal to 0 and L2x plus M2y plus N2 equal to 0 are conjugate lines with respect to the circle x square plus y square plus 2gx plus 2fy plus c equal to 0. Second point: a r square into L1 L2 plus M1 M2 which is equal to L1g plus M1f minus n into L2g plus M2f minus n2. We'll see the proof. Given circle is x square plus y square plus 2gx plus 2fy plus c equal to 0, that is equation number 1. Given lines are L1x plus M1y plus N1 equal to 0, that is equation number 2, and L2x plus M2y plus N2 equal to 0, that is equation number 3. So 1 implies 2. We are going to prove if 2 and 3 are conjugate lines with respect to the circle 1, then we need to prove r square into L1 L2 plus M1 M2, which is equal to L1G plus M1F minus N, L2G plus M2F minus N2. So since 2 and 3 are conjugate lines, so by the definition pole of 2 lies on 3. We know pole of 2 with respect to 1 is minus G plus L1 r square by L1G plus M1F minus N, comma minus F plus M1 r square by L1G plus M1F minus N1, where r is the radius of the circle 1. Since pole of 2 lies on 3, so put x is equal to minus G plus L1 r square by L1G plus M1F minus N, and y is equal to minus F plus M1 r square by L1G plus M1F minus N1 in equation number 3. So we will get L2 into, instead of x you are putting the value, right, minus G plus L1 r square by L1G plus M1F minus N plus M2 into minus F plus M1 r square by L1G plus M1F minus N1 plus N2 equal to 0. That is minus GL2 minus FM2. So just we are multiplying, simplifying, right? Then minus plus next term L2 L1 r square by L1G plus M1F minus N1 plus M1 M2 into r square by L1G plus M1F minus N1 plus N2 equal to 0. That is minus GL square L2 plus FM2 plus N2 plus, so common denominator for these two terms, right? So taking common denominator L1G plus M1F minus N1, then in numerator we will get L1 L2 plus M1 M2 r square, which is equal to 0. Therefore the remaining term take the minus outside, so minus GL2 plus FM2 minus N2 plus the remaining this term L2 L1 plus M2 M1 into r square by L1G plus M1F minus N1 equal to 0. Therefore L2 L1 plus M2 M1 r square by L1G plus M1F minus N equal to GL2 plus FM2 minus N2. We are taking that left hand side term to the right hand side, right? So thus 1 implies 2 is proved, right? We need to prove like this, right? That is, you just cross multiply, you will get the standard result, that is 2, right? L1 L2 plus M1 M2 r square, which is equal to L1G plus M1F minus N1 into L2G plus M2F minus N2. Next, 2 implies 1, right? If and only if condition. Suppose L1 L2 plus M1 M2 r square, which is equal to L1G plus M1F minus N1 into L2G plus M2F minus N2, then we need to prove 1 is true, right? So that means, so we are taking L1 L2 plus M1 M2 r square, so divided by L1G plus M1F minus N1, so remaining, which is equal to GL2 plus FM2 minus N2. We are taking that only one term L1G plus M1F minus N1 from right hand side to left hand side, it will go to denominator. So that is minus GL2 minus FM2 plus N2 plus just reverse of the above terms, right? Plus L1 L2 plus M1 M2 r square by L1G plus M1F minus N equal to 0. So dividing, so just if and only if on the reverse, right? This implies minus GL2 minus FM2 plus L1 L2 r square by L1G plus M1F minus N plus M2 M1 r square by L1G plus M1F minus N1 plus N2 equal to 0. So this can be written as grouping first L2 term L2 into minus G plus L1 r square by L1G plus M1F minus N1 plus M2 minus F plus M1 r square L1G plus M1F minus N1 plus N2 equal to 0. That is equation number 4. So we know that pole of 2 with respect to 1 is minus G plus L1 r square by L1G plus M1F minus N1, comma minus F plus M1 r square L1G plus M1F minus N1. So 4 implies the pole of 2 satisfy the equation L2x plus M2y plus N2 equal to 0. So pole of 2 lies on 3. So line 2 and 3 are conjugate, right? Pole is on the other one. right? Pole means the point, right? That point is on the polar of that one, then two lines are conjugate, right? So 2 implies 1 is proved. Two lines L1x plus M1y plus N1 equal to 0 and L2x plus M2y plus N2 equal to 0 are conjugate with respect to the circle x square plus y square equal to r square if and only if L1 L2 plus M2 M1 r square, which is equal to N1 N2. There is no G F term, both are, and C also, right? All are 0. Thanks.